I would like to talk to you about the Module Analog Research Station, the Mars habitat. We've heard a great talk previously about the Brazilian Martian habitat. We are also in a process of building one of these habitats. We built it in Poland, Europe. We started, I don't know if any of you were 2 years ago on the Houston Mars Society Convention. We started as a team that was part of the student contest, the Inspiration Mars. Right now we're also part of this contest, so I just came back from presenting the contest, so to come here. So after the Inspiration Mars contest, we thought that the cooperation with our team, inside our team of 10 people, was going really well, and we decided to take part in the NASA 3D Print Habitat Challenge. And it went very nice. We had a couple of architects on team, so we got into the finals, and the competition is open-ended. So the first one to actually present the technology to print the 3D print a habitat with the soil will receive a prize of, I believe, $2 million. So it's like X Prize or other type of NASA contests. But we went further. We decided we want to build an analog Martian habitat in Poland. It would be the first habitat in Europe. So we made a design, we made a study of how it's supposed to look. We were part of 17 teams that were cooperating on this. So we were the part of the design and the testing. So what we did basically was start a crowdfunding campaign to get the attention of the media, hoping to get a big sponsor. So we raised around 30,000 euros on our crowdfunding campain. However, we did find a nice sponsor, and we managed to gather up around 200,000 euros to build it. So, we don't have the picture here. So this is where we build it. We build it in Poland. We do not build it in a very remote location. It's around 3-hour drive from the nearest city. And this has some disadvantages, but also it allows us to be much more flexible in terms of our mission, how we can deliver the crew and deliver other scientists for the mission to see the astronauts. This is what the overall plan of the habitat looks like. We have a central dome that would be 8 meters in diameter, and we have 6 containers that are put around it. So the first one is the entrance container. This is the one that the crew will use to enter the habitat and then stay during the whole stay of the mission. They will not use this container for other stuff. We have the greenhouse container, which would have the equipment for all experiments. We do not think that, we think about cooperating, we already cooperate with European Space Agency on this, and we decided that to not be interested in the results of the experiments, but sort of look at the experiment as a process of experimenting and trying to fiddle with it a little bit. So in the future, with any agency, NASA, ESA, or China, or private corporations will decide to actually build this kind of stuff, they can look at the experiments as a way of having them in orderly and make them orderly and as quickly as possible. So we're asking astronauts to do this kind of experiments, but we are looking for the feedback from them, as they can say, if we do this in that direction or in this way, we can trim off the time of the experiment with the same result. Okay, I'm having problems with the presentation. I will try to pull it on the website so the pictures are proper, because yeah. So we basically are in the process of finishing the building of this habitat. We have the dome, we have the containers ready. We basically are trying to finish it up before the winter, so we do not have to refurbish it after the winter. Yes. This is one of the experiments that the astronauts could be performing. What? A dessert? That's a dessert. Those are cockroaches. And we are cooperating with companies that are working in Poland. For example, the Hypromine, who are what they do is create protein from the organic material. So we could see how efficiently and quickly we can grow these cockroaches on the station in a controlled manner, of course. And we could then use the bioreactor that the Hypromine provides for us in order to turn it into protein and then add it to the meals, so they can like sort of look at the closed loop that we might be facing in the future. This is the crew quarters. We were inspired by the Japanese hotels, these very small tubes, basically like a very small tent, and you can crawl in. Because of the small volume of the habitat, we were thinking that any place that the crew member can have some sort of privacy would be valued by them. So those things have sliding doors, and this is what one looked like. They would have shelves on board and they would sleep inside. This is how the building of it looked like. They were basically made with plywood, but because we think that the huge immersion that you can have in this sort of habitats can be sometimes not very efficient in terms of being flexible with your experiments. So if you can make something, we could do it with the aerospace grade materials and see how they all work together. But what we're trying to do is to have the crew, the astronauts basically, to have the operations for them ready. So the operations, the manuals, the checklist, this is what we are thinking would be the biggest purpose of this habitat. This is the hygiene compartment. This hygiene compartment contains of a shower, toilet. We would utilize the gray water, so we don't have to flush the toilet with cleanable water. It doesn't have to be perfect. It just has to be flushed. And we also have the workshop here. The idea is that the crew might pull something from outside, and we want to have it near the hygiene compartment so they can basically run it with water. We do not want the soil material inside the habitat for many purposes, but so it's like when you go to the beach once, you find the sand in everywhere forever, right? So we want to keep it as clean and as simple as possible. So all the astronauts, before they come in from outside, they will be showered very thoroughly, and preferably they would leave the suits outside. So they would just leave it in the airlock and then just use them inside, but still try to keep it as clean as possible. This is the laboratory module. We would have the clean lab and the dirty lab with the airlock, of course, and they could. We are working with 17 universities in Poland that will provide scientific equipment for us, and they will be able to perform all sorts of experiments on board. And we have, of course, the kitchen and storage, and we have the main part of the habitat, the dome, which is designed in a way that could be reorganized very quickly and easily. So it could be used as a dining hall and then quickly be reorganized into a meeting orientation. This is how it look like after it's finished. It's not finished at the moment, but I believe that there are people, there are actually workers on the site finishing it as we speak. So what I would do, what my job in this project was the evacuation. What could go wrong? I would sit all days and think of what if the electricity goes out and we have a puncture in the habitat. What's the best way of doing it? And so the crew doesn't die as often as they might have. So my job was to make astronauts die as rarely as possible. But what we are looking at would be, in the long duration missions, would be to check those checklists, to make astronauts have those problems, and to see if they do things by the checklist, if everything goes fine or not. And if not, that's great, we can upgrade those checklist, and it's actually a science return for the mission. So how the astronauts should operate. I was also thinking maybe in the future have the EVAs, and have the EVAs designed in a way that they would be asked for never to separate. Two astronauts should never be separate, but they would see that if they do it alone, they would be able to do everything twice as quickly. So my idea was to wait for them to separate and then just snatch one of the astronauts and never tell anyone what happened to him and see how the crew reacts, to see how the checklist is. They might go looking for him, or they might just say the risk is too high and we need to stay at the habitat and just say bye to Chris, right? This is our crew. We at the start of this year, January, we made a media campaign in Poland and in Germany and Holland, where the ESTEC, the ESA headquarters is, where we cooperate with, and we have team of 6 astronauts that we are training for the missions, and they are mostly technical with the technical degrees, but we also have a doctor on board. So we also cooperated with the psychologist who helped us pick the right people, so they wouldn't fight as much as possible, but we'll see how it goes in the future. We already performed one workshop for the astronauts for them to be ready, and it was a 2-week tryout mission where we tried to, as quickly as possible, go through all the checklists and problems that they might occur, and also have this dry run of the mission so the crew can get comfortable with each other. So we see here the day composition, and we see that during the mission they were actually shifting the day further to the night so they could perform the night EVAs. The idea for this was that the crew could operate the rovers during the night, because this is one of the astronauts. This is the daylight EVA, and we were thinking about, there was this paper I read about the corrosion of the Curiosity wheels, and the Curiosity operates during the day. It makes some small holes, see if it finds anything, and the idea was that maybe the liquid or water or whatever it is comes up during the night where the rover is not operational, and then once the day comes, he wakes up, makes a drill, nothing is there because the water is already down. So the idea was to train the astronauts to perform also the night EVAs and to have them all the checklists possible. They made the drills, they were training to pick up the samples and examine them later. So we're thinking about in the future. We are cooperating now with ESA. We're thinking about also having missions organized for ESA in the future. So the idea is to sort of lease the habitat for space agencies, to have their astronauts or maybe their teams perform missions inside of it. But still we're thinking about it will take only half of the time that the hub is operational. The other 10% roughly would be in the maintenance between the missions, but we have a very large, like almost 40% amount of time that the habitat would actually stand alone. We are thinking about making long duration missions, maybe 500 days, maybe a year, but that's years into the future. Right now we're thinking about month, maybe 2-month missions at the moment. So the habitat would be empty some of the time, and we're thinking to use this time because we are not getting paid by the government on everything. We just found a sponsor, so we need to think about this as a business model too. So we're thinking about making a outreach for the children and the STEM, all this kind of stuff, to just drive the children in there and to make them see all this kind of stuff, to make them excited about working in the space industry. We're thinking about outreaching to a corporate client to sell them this kind of team building exercise. You can think of like when you're having a tiger team that has to be very close together, you can just close them for 2 weeks and make them familiar with each other really quickly. And we also are thinking about weekend leases. It doesn't have to be necessarily weekend. We could, on the special occasions, if the habitat is free, we could also lease the habitat to private people for example, to have a New York Eve in the habitat. And this is why I was talking in the beginning about how the location is not very remote, but it's far away into the mountains. So now it's safe from the prying eyes. However, we are close by to the big cities like Prague, Berlin, Warsaw, Vienna, where we could find the clients for this kind of stuff. And in the beginning, where we do not have this big government leases, we might actually be able to stay afloat because of the corporate and private leasing of the habitat. So thank you for your attention. This is how it would look like probably before this winter, and I'm looking forward for questions from the audience.
The way this location is it just remote, or what's the weather like there? Is that like any analog to like a desert or anything else?
It's not a desert. It's a mountain. It's the top of a small mountain in the Tatra Mountains, but it's good because the soil around it has this gray color to it, and there is no organic activity going on around there. So the astronauts, when they go on the EVAs, they do not really see them green stuff and everything. So this is the con of having it not in the desert. However, in Europe, we do not have abundance of the desert, and we believe that there is still need for this kind of analog habitat.
How much would you lease it for?
We do not know yet. We would have to, after it's finished, we would have to see what the operational costs are. So the leasing, that maybe visiting it, we would have to, for the beginning, we would have to hire probably 1 or 2 people who would be able to perform the tours around it. And then we would have to see how much cost it is actually cost to heat up, make all the payments for the media, and probably we'll just lease it in a way so we have little bit more than we spend on it. So we are just afloat. All of us have daytime jobs. We just did it sort of in a spare time. So we do not have the immediate need to make it financially successful.
Which mountain range?
Wait, what?
What mountain range was it?
It was Tatry Mountain. Tatry Mountain in Poland. Tatry.
Don't know it. How do you spell it?
Tatry.
How did you come up with the 9.1% maintenance? Was that based on previous studies of other stations? Or
Yes, also we also thought about having it rearranged because it contains 6 modules. We are flexible enough, for example, to have a government mission say we need to have a very, very small like area of the mission, so we can have all the different modules just shipped out. So, and then maybe have different modules shipped in if there's a need for a bigger habitat. So this is why we needed to. We also looked at the time that we can just have the truck come up there, because it's tricky, especially in the winter, because it's the mountain range and you need to have a specialized truck ready, and it shouldn't be raining for 3 days prior, or the truck there is way too much slippery. So we're also looking at that, and we also were thinking about or it could be easily a Mars habitat as well as a lunar habitat, especially looking at the ESA's current goals. Last year I was on the ESA's Moon 2020-2030 conference, and they are really focused on the moon right now, especially robotic human cooperation on the moon, and way in the future they're planning to have a lunar habitat. But we think sooner than later they will have to train the astronauts for the surface operations.
What motivated this sort of polygon cross-section to your arms as opposed to circular?
Those arms, this is actually the cross section is actually square. However, in this render we have all the habitat covered in the dirt as a way of simulating the radiation protection. So we are not. If there was a long duration mission, we would cover it with dirt. But during the short duration missions where the habitat should be reconfigured very quickly, we are not thinking about
So it's a
covering.
rectangular cross-section, you
Yes,
just
it's
put
just
it on.
it's just a plug, so
Alright.
the container structure do not get damaged by the contact with the soil.
Okay.
Okay, thank you very much then.